Welcome. Our project deals with the smart helmet, and the group members are from left, Frederick Moseki Dheka, Brian Mtembei, Hesbon Ogungo, Solomon Hamisi, and Gloria Mwangi. The main objective of the Smart Helmet project is to design, develop, and implement an integrable wearable devices that enhances riders' safety and convenience through the incorporation of advanced sensor technologies, seamless communication capabilities, and real-time information feedback. Objective number one is to design and integrate sensors module, e.g., that is accelerometer, gyroscope, GPS, ultrasonic distance sensor, and communication module, that is Bluetooth, into a functional helmet prototype. Second objective is to utilize accelerometer and gyroscope data to accurately track the rider's head movement, providing real-time orientation information. Third objective is to implement GPS functionality to track the rider's location, allowing for real-time navigation assistance and tracking. Fourth objective is to integrate an ultrasonic distance sensor to detect objects in the rider's blind spot, providing timely warning. Second last objective is to develop a display system, that is through LED, to present relevant information to the riders in real time, such as speed, direction, and distance. The sixth objective is to establish a Bluetooth connection between the helmet and the smartphone, enabling features like hands-free calling, data transfer, and remote. So in our devices, we are not going to see the Bluetooth device because the MPU 9250 that we are using has Bluetooth components in it already. Then connection of all the components. And some of the components that we used include GPS module. We also have gyroscope. We also have MPU 9250, which is molded with Bluetooth component for seamless communication. We also have ultrasonic sensor. Here we also have connecting wires. The connection was made possible by the use of breadboard. And as per the requirement of the lab rules, we had to confirm that the connection are properly done before we go further. Yeah, so just the checking process. We also used the cable, USB cable. We developed a code, then compiled it. The reason for compiling a code was to confirm if it was well developed. Then we waited for the compiling process and then uploaded the code to check whether the ports and any other selections was correctly done. Here we had to wait for some time, still uploading, as you can see. Yeah, it's still uploading. We have to be patient, a little patient here. Wow, done uploading. So we clicked the serial monitor to observe the data recorded from the project. So we had to reboot it, to reboot the connection, just for us to observe or for the recording to be made possible. And as you had seen, we just got the data that we expected. Now, upon trying to make some changes in orientation, adjusting, making some necessary adjustment through moving of objects. Yes, as you can see. Yeah, Now upon making the changes, we can see that the reading keep on changing also, that is depending on orientation and change of distance. So you can see there, yeah, very nice. It keeps on changing, meaning this far we had made a good progress. So this all this process was we were helped by our own Alex Kimuya, who was very strict in ensuring that the lab rules are followed, codes are well developed, and so on. So we can see there is a acceleration and velocity in both x, y, and z axis. Of course, velocity is measured in meters per second. Then angular momentum in x, y, and z axis. You also have pitch in terms of degrees, yaw, and roll, so on. So up to this far, we are going now to take a screenshot and try to analyze it. So here we can see that acceleration is given in both x, y, and z axis. We also have velocity and angular momentum. So acceleration, velocity, and angular momentum are given in both x, y, and z axis. Orientation is given in terms of yaw, pitch, and roll. So that is all about the project. Thank you.